A powerful language model can still give a poor answer if it receives the wrong evidence. Welcome. In this video, we will explain the production-grade retrieval strategies behind RAG systems. The language model writes the response, but retrieval decides what information it sees. Why does retrieval matter so much? Because the retriever sets the evidence boundary for the LLM. When it finds the right policy, code example, or troubleshooting note, the answer can stay grounded. When it retrieves incomplete, outdated, or unrelated content, the model may sound confident while being wrong. A confident answer based on the wrong document is still the wrong answer. In production, retrieval is a pipeline that searches, filters, ranks, and assembles evidence. There are two groups to keep separate: sparse, dense, hybrid, structured, graph, and multimodal retrieval are actual ways to find candidate evidence. Metadata filters, reranking, multi-query, query decomposition, HyDE, parent-child retrieval, and MMR improve what happens around that search. They can improve recall, precision, security, or context quality. Not every useful retrieval component is itself a retriever. Keeping that distinction clear makes the rest of the design easier to understand.
Here is the learning path we will follow.
First, sparse retrieval for exact words, identifiers, and codes. Second, dense retrieval for meaning and paraphrases. Third, hybrid retrieval, which combines both. Then we add production controls through filtering and re-ranking. Finally, we use specialized retrieval when the answer lives in SQL data, a graph, or visual content. This sequence moves from the most common foundation to use case specific options. Sparse retrieval, usually BM25, is an exact term search approach. It is strongest when the important signal is a word, code, identifier, or formal phrase. Think of error messages, table names, product IDs, legal wording, and API names. For example, a query containing ORA 00942 and the customer master table should strongly favor documents containing those exact terms. The limitation is vocabulary mismatch. A relevant document may be missed when it explains the same issue using different words. Dense retrieval searches by meaning. It converts the query and document chunks into embeddings, then finds vectors that are close in semantic space. This helps when the user and the document express the same idea differently. For example, remove and employee system access can match staff offboarding and account revocation. Dense retrieval handles natural language questions and paraphrases well. Its weakness is that short codes, exact identifiers, and specialized tokens may lose importance inside the embedding. Sparse and dense retrieval are two different specialists. Sparse is the exact matcher. Dense is the semantic interpreter. If the query contains a code, ID, or exact policy phrase, sparse often has the advantage. If the user describes a concept in different words, dense often performs better. Real enterprise queries frequently contain both. A troubleshooting question may include an exact error code and a natural language description. That is why production systems often combine both approaches. Hybrid retrieval lets both specialists work together. BM25 finds exact technical signals, while dense search finds semantic matches. Their ranked results are then combined using a fusion method such as RRF or reciprocal rank fusion. Fusion is useful because keyword scores and vector similarity scores are not directly comparable. For mixed enterprise content, hybrid retrieval is often a strong production starting point. It is not automatically perfect, but it covers both exact language and meaning before re-ranking. In production, relevance is not enough. The system must also search within the correct business and security boundary. Metadata filters can restrict retrieval by tenant, department, region, document type, language, version, status, or effective date. ACL filters make sure users retrieve only content they are authorized to access. These controls should be applied during retrieval, before evidence enters the context window. Filtering only after generation is too late because the wrong content has already reached the model. The first retrieval stage is mainly about recall. It gathers a broader set of candidates that might contain the answer. Reranking is the second stage that improves precision. A reranker evaluates the query together with each candidate, then moves the most relevant evidence toward the top. This can produce a major quality improvement, but it adds latency and cost, so it should run over a limited candidate set. A reranker cannot rescue a document that the first stage never retrieved. Query enhancements are useful when the original query is vague, incomplete, or complex. Multi-query creates a small number of alternative phrasings, retrieves for each one, then merges and deduplicates the results. Query decomposition breaks a multi-part question into smaller questions and retrieves evidence for each part. HyDE creates a hypothetical relevant passage and searches for documents with a similar representation. Each technique can improve recall, but each also adds cost and possible noise. Use them to solve a measured retrieval problem, not simply because they are available. Finding the right candidate is only part of the job. The system must also send enough useful context to the LLM. Parent-child retrieval searches smaller child chunks for precise matching, then returns the larger parent section that contains definitions, steps, and qualifications. MMR, or Maximal Marginal Relevance, addresses a different problem. It balances relevance and diversity so the final context does not contain several near-duplicate chunks. Parent-child improves completeness. MMR reduces repetition. Some questions should not go to a document index at all. If the answer is a count, current status, transaction, or exact record, use structured retrieval through SQL or an API. If the question is about lineage, ownership, or dependencies, graph retrieval can traverse the relationships directly. If the evidence is inside diagrams, charts, screenshots, scanned PDFs, or slides, multimodal retrieval is needed. Vector search is useful, but it is not a universal answer key. A production router should send each query to the source that actually holds the answer. Here we see the practical selector view. For exact terms, codes, and IDs, start with sparse retrieval. For meaning and paraphrases, use dense retrieval. For mixed enterprise content, use hybrid retrieval. Add metadata and ACL filters for scope and security. Add reranking when the final order of candidates needs improvement. Use decomposition for multi-part questions, SQL or API retrieval for structured facts, graph retrieval for relationships, and multimodal retrieval for visual evidence. The method should follow the information need. Let us bring the complete production pipeline together. Prepare the query, apply metadata and ACL filters, run BM25 and dense retrieval in parallel. Fuse the results, re-rank the candidates, expand the selected parent context, and generate the answer with citations. The goal is not maximum complexity. The smallest useful combination wins. A production RAG system should use only the strategies required to retrieve context that is accurate, relevant, and authorized. Thank you for watching.